Hey guys, welcome to another online math class. This video will be about linear modeling. And by the end of this lesson, our goal is to be able to identify the gradient and y-intercept from worded information, be able to write a linear model from worded information, and finally be able to make predictions using a linear model. Let's just pause the video here and take a couple of minutes to write these down. Alright, so linear modeling is the process of describing real-life relationships between two variables. And this is often used to solve problems in the real world or make predictions. And some examples of these are the time taken to fill a swimming pool with water, estimating a car price after a period of time, or describing plant growth over time. So these are just a couple of examples. There's much more different ways linear models are used in the real world. So let's look a bit closer at plant growth. So in this given scenario, when the plant was first planted, it was 5 centimeters tall. And it also says the plant then grows at a constant rate of 6 centimeters per week for the next 10 weeks. And it's going to ask us to construct a linear model here. So there's a few things we need to know before we do this, and the first one is that the rate is the slope of the gradient. And if we look at the scenario before, it says the plant grows at a constant rate of 6 centimeters per week for the next 10 weeks. So it's got our rate there, and therefore in our equation y equals mx plus c, that value is going to be m. The next thing we need to know is that the starting point is the y-intercept. So going back to the scenario again, it says the plant started at a height of 5 centimeters, and that is our y-intercept, so therefore it is c in the equation y equals mx plus c. So let's pause the video here and write these down because that will be important for this topic. Alright, now moving on to the steps that we need to follow. Our first step is to look at the units for the starting position. And the scenario said when first planted, the height of the plant was 5 centimeters. So in this case, this means our y value is referring to height there. So whatever your y-intercept is, in this case it's height, that is what your y value is going to mean. And step 2, the next step is to replace y and x with the appropriate pronumerals. So like we said before, we said y will refer to height, so we can replace y with h. And this will mean x will have to be time because we're using time to predict our height. So that means we can replace x with t. So if I do that here to y equals mx plus c, I've got h equals mt plus c. All I've done was replace y with h and x with t. Once we've done that, we're going to substitute the numbers of m and c into the equation. Just remembering that m is rate and c is the starting point. And using that equation h equals mt plus c, we know that our rate is a value of 10, a value of 6, sorry. That's my rate there, equals 6 centimeters per week. So I've got that here, h equals 6t. M is going to be 6 and it starts at 5 centimeters. So my C value is going to be 5. That's where I get this equation, h equals 6t plus 5. So that's our linear equation or linear model for this scenario. There's just one more thing we need to include. And just note that it says for the next 10 weeks. So we're making predictions from 0 weeks all the way to 10 weeks. And we've got to show that as a piece of information as well. And we're using weeks as time here, t for time. So we can write it like that below there. So that means our predictions start at 0 weeks and end at 10 weeks. So an accurate reading of those symbols would be, this rule applies to when t is greater or equal to 0 or smaller or equal to 10. Alright, so that's how we create a linear model from worded information. This may seem a bit difficult at the start, but with a bit of practice, you'll get a bit used to it. So once again, once you've identified what y is referring to, in this case it's a height, that's our first thing we need to do. Once we do that, we need to find out what x is referring to and replace that with whatever it is. In this case it's time. And then find out what the gradient and the y-intercept is and then substitute those values in. So that's a brief rundown of the steps. Once we've got a linear model, we can use it to make predictions. So an example problem you might get is predict the height of the plant after 8 weeks. So this is using the linear model we made in the previous slide. And remembering that our equation was h equals 6t plus 5. So when it says 8 weeks, that's referring to t equals 8. So I will need to substitute t equals 8 into the above equation, and that gives me 6 bracket 8 plus 5, which means 6 times 8 plus 5. That will give you 48 plus 5, so h equals 53 centimeters. So in words, your answer might be the predicted height of the plant after 8 weeks is 53 centimeters. And if you've got a graph like this, you can just read it straight off the graph. Just jump to 8 weeks over there and go up until you hit the line, and you'll see that's at about 53 there. Alright, so that brings us to the end of this lesson. Hopefully you guys did get something out of that. And hopefully by now you guys are able to identify the gradient and y-intercept from word information, can also make a linear model from word information, and finally can make predictions using a linear model. Thank you guys for watching, and I'll see you guys all back online.